Good afternoon. Welcome to MCC at DoSpace, and I'm glad that you could join us today. My name is Sally Hopley, and I am MCC's Coordinator of Sustainable Practices. I'm thrilled to welcome you to the 6th presentation in the Hubbard Sustainability Series. The goal of the Hubbard Sustainability Series is to showcase dynamic sustainability experts to the entire community. To achieve this goal, MCC at DoSpace has developed a series of presentations, each featuring sustainability superheroes and providing them at no charge to the viewing public. Today's topic is renewable energy, and what an important time to have such a conversation. As the impacts of climate change become more apparent, renewable energy is key to a healthier and a safer future. I'm glad you're here today because only with an informed community can we gather together to tackle local environmental challenges and have a positive impact on our planet. I'd like to give a special thanks to the trustees of the Claire M. Hubbard Foundation for providing the resources necessary to support this important endeavor at no cost to the public. Your generosity is much appreciated. Please join me in thanking them for their support. Thank you. And now for the event you've all been waiting for. Please allow me to introduce our first speaker. Courtney Kennedy is the manager of Alternative Energy Program at Omaha Public Power District. Her team is responsible for the research, development, and execution of grid-scale renewable energy products in support of OPPD's resource planning and strategic directives. Courtney has 6 years of experience at OPPD, including projects focused on operations, analysis, process improvement, and strategy. She was a key driver in the development of OPPD's initial electric vehicle strategy and pilot program. Courtney holds a BS in mechanical engineering and Spanish from Iowa State University and an MBA from Creighton University. Please welcome me in welcoming our first speaker.
My speaker working? Try to sit over here. Thank you so much for having us. As she mentioned, I'm Courtney Kennedy with OPPD, and very honored to be here today to talk about what we're doing. So kind of a high-level overview of what we're going to talk about. For those of you maybe not familiar with OPPD, we'll give a quick overview. I promise it won't take long. Talk a little bit about how the landscape is evolving, what we're doing with local energy, where we are today, and what's up for the future. So real quick, just want to hit on OPPD's vision, mission, and core values. And this is really important to kind of set the context of where we've been and where we're going in the future. Our vision is leading the way, we power the future. Our mission is to provide affordable, reliable, and environmentally sensitive energy services to our customers. And this is really important because it's a continuous balance of affordability, reliability, and environmental sensitivity. And then the last piece here is our core values. And this is something we do truly live out in the way we have a passion to serve, we honor our community, and we care about each other. So this is kind of important context for what we do every day. Just a quick slide on OPPD by the numbers. We serve almost 850,000 people. And I won't read all of these to you, but we have about 5,000 square miles of territory across 13 counties. So we have both urban populations and rural populations. We have 8 publicly elected board members, but we're ultimately one community. And so it's how do we serve our customers across this range of area the best way. So as we are asked to talk today at a sustainability event and really focusing on renewable energy, I wanted to provide a little bit of insight into how we look at our decision-making and strategies. OPPD has 15 strategic directives that are set by the board. And these are policies that help us establish clear goals. One of those is environmental stewardship, number 7. And so that's really what sets our goals in terms of carbon intensity reductions as well as renewables. Recently, our goal was changed to 50% renewables as a measure of energy sales supplied. So we'll get into a little bit more about how that's evolved over the past. So let's talk about the evolving energy landscape. As you drive across Iowa or Nebraska, likely you've seen more and more wind turbines popping up. It's exciting. The whole energy industry is changing. And so it's exciting to be part of that. Whoa, I gave away some of it. Okay. So real quick, a little bit of difference in alternative energy and in renewable energy. There's many different definitions. People might categorize them differently. If you look at what the Environmental Protection Agency or the EPA categorizes, generally it's more of the items on the left: wind, solar, biomass, sometimes hydro. And as we move to energy storage and microgrids, these are evolving technologies that allow us to do more with those resources. So for those of you that maybe aren't as familiar with some of these, I wanted to give a quick overview of the technologies themselves. Let's start with wind energy. This is a nice image I borrowed from GE. But as we know, there's a lot of wind. It's caused by changes in surface temperatures, which cause air to move. So it's great because we have wind all over the earth, and we can leverage this technology to capture that energy. The blades capture the energy, and they spin the generator, and we get electricity. Wind has been around for a long time, whether it's pumping water out of the ground on farms or evolving to electricity on very large scale. But there have been even innovations recently, and some of those are coming up with taller towers, larger turbines to get more energy produced on a smaller footprint. But there's also the development of offshore. That's not as likely of a prospect for OPBD, being that we don't have a coast, but it is exciting. It's a little jumpy. All right, so this is just a quick snapshot of wind potential in the US. And if I can get this right, as you can see, Nebraska is in a great spot with the purples and the blues being the highest potential with great wind speed. So that's why you really see wind energy taking off in the Midwest. Solar energy, there's two common types you hear about: photovoltaic, or PV, or thermal energy. Photovoltaic is probably more common in terms of utility applications. Thermal is generally used for water or concentrating solar. Solar is a great resource. It does have some challenges in terms of implementing, and that it requires quite a bit of land to get really large-scale amounts of energy. It's not impossible, but it's something as we look at projects to consider. There's a lot of innovation and projects happening with residential versus utility scale. We'll talk a little bit more about those. Innovations for solar energy have been a lot of the components, and this is kind of where the excitement is as we look at larger scale applications. This image here is showing the tracking. So no longer do we have to just fix a panel and hope it's pointed the right way for the sun, but we can have it track and follow the sun. We have module enhancements, different technologies beyond silicone, and enhancements for their efficiencies. Smart inverters, which really, when we're talking about integrating to the grid and being able to use these resources more smart than just energy, there's been a lot of innovation in that area, and that's really exciting from a utility perspective. And then finally, floating solar. This is an interesting development, and it'll be exciting to watch. They're actually finding that putting solar in lakes makes it more efficient. It has a natural cooling effect. There's just the challenge of how do you get that to the shore to use it. So that'll be fun to watch. Here's another map of solar potential for the US. Perhaps not a surprise, the Southwest gets a lot of sun, so it has the greatest potential. But again, Nebraska is not doing too bad. Hydro, for those that aren't familiar, water spins the turbine and creates electricity. This is about 7% as of 2018 for US utility scale generation. Innovations, this technology has been around for a while, but innovations include pumped storage, which gets into another category of technology, and then low impact small hydro. So rather than taking a full river and damming it up, there may be ways to only impact part of it where you're not affecting the whole ecosystem of the river. So some developments that have been taking place there. Now, biomass energy covers quite a span of different organic waste, but it's essentially getting energy from that. You burn the biomass, create energy, and heat up water to steam to power a generator. Landfill gas is a common one, and that is something that OPBD has had for quite a while. Other forms are in this photo here. We can use agricultural waste, sewage, municipal waste, animal residue. So there's a lot of opportunities potentially to integrate this more into the future. The last kind of technology we'll talk on is energy storage. And I think for those of you that follow along the trends and changes in the energy industry, this one's all over the place. It's really finally the ability to be able to store energy and use it at a later time. And so if you look at like wind energy, in especially Nebraska, it produces the most at night when not a lot of people are using electricity. So this gives us the capability to store that and use it later. Batteries are probably the most common, and especially lithium-ion right now. However, there are many different technologies that are competing and evolving. The picture on the bottom there is pumped hydro. We have thermal, flywheels, hydrogen, compressed air. Some of those make more sense in other places. We don't have a lot of elevation in Nebraska, for example, so pumped hydro is going to be a challenge. But this is something we continue to monitor as costs come down, technologies evolve, and applications get more and more realistic for our uses. So that's a little bit, just a quick snapshot for those maybe that weren't as familiar with some of the renewable energy and alternative energy technologies. What I want to get into is more local. And this is where it gets exciting. So I showed you the maps earlier of potential for wind and solar across the US. When we zone in on Nebraska, Nebraska is actually 4th for wind potential in the US. That doesn't mean we have the 4th amount of generation, it means that we have great potential for it. For solar, we are about 13th, so that's pretty good. We're in the top half of the states. This is exciting for future development for solar. One of the challenges that has been with renewable energy is sometimes the best places for the production are the hardest to get to the users, the load. And so that's an ongoing debate of how do we build enough transmission, or how do we site this in the right way to get it to the users. When we look at OPPD, it's a pretty neat story that all of our renewable energy is here in the state. So these are all the wind farms, and we'll talk a little bit more about how our portfolio is evolving. But these are all the wind farms that OPPD has power purchase agreements with. Our community solar that'll be coming online later this year, and then our Elk City gas station. So it's neat that renewable energy is really local. So where are we at today? I started to hint at some of it. First, I'll talk about what our portfolio looks like from a nameplate capacity, and then we'll talk a little bit about how much is actually covering our load. With another wind farm, Shoals, coming online here at the end of the year, we'll be almost to 1,000 megawatts of wind. We're pretty excited about that. Solar, we don't have as much, but as prices come down, we'll start to look at how that fits into the portfolio. Our first facility will be online here later this year as well. Landfill gas and hydro also make up that portfolio. So what does that mean for covering our load? I like this story, and I like to see the growth that we've had in the last 9 or 10 years. Back in 2010, our first goal for renewable energy was to be 10% by 2020. As you can see, we hit that in 2013. So then we said, well, what's next? Let's get to 20% by 2020. Well, we hit that somewhere in between 2016 and 2017. Last year, the board set the new goal to be at 50%. So as you can see, we continue to add and change our generation mix. That is growing, but we still have room to go. Once Shoals comes online later this year, it's a 160 megawatt farm, will be somewhere close to 40%. Up here on the right, last year was our 2018. It was about 32% of our retail energy sales were served by renewable energy. And this is important. The last slide is just nameplate capacity. This is actually what our units did to perform and cover our customer load. So that's kind of a broad perspective of utility scale, how we're serving our load from renewable energy. I also want to spend some time talking about a few other items in terms of customer programs and some of the other efforts we have going in the renewable energy and sustainability arena. I will put a huge caveat that I am not an expert on all these programs, so as you have questions, we have people at our booth that can help. But we have some great programs going on around electric vehicles, energy efficiency, with AC load management, smart thermostats, smart HVAC rebates, and then we do a lot with our large-scale customers on how do we reduce their energy usage and use it more smart throughout peak loads and times of higher prices. So there's a lot of great products out there, and as you have questions, I encourage you to reach out and ask us. So as I mentioned, community solar, this is pretty exciting in a couple of different ways. The first one being, this is our first utility-scale solar project in our territory for OPPD. This is a 5 megawatt facility outside of the town of Fort Calhoun, not at the station, but outside of the town. This will be operational later this year. In addition, it's a community shares program. So that meant our customers, and some of you in this room may have bought into that, are really part of this program buying into this. So if you don't have the ability to put solar on your rooftop, whether you rent an apartment or a house or you have shaded trees, this was an opportunity to get into solar. We're really proud that we had 8,400 shares for sale, and those were sold out in the first 49 days. So we're excited to see this come online and really to grow into the program. Additionally, we've spent a lot of time in the last couple of years driving electric vehicle adoption. When we started looking at this a couple of years ago, there were probably only about 500 or 600 electric vehicles in the state of Nebraska. It wasn't very high. So we started reaching out to customers and saying, why is that? What does it take to get you to drive an electric vehicle? And we started to understand what the barriers of adoption are. We found that there was pretty much 4 categories. One was a lot of people didn't have education around an electric vehicle. They thought the range was very small, they didn't understand it. So that was one barrier. The next one was not understanding how they would charge this thing. You can drive down any street and see a gas station, you're comfortable, you know you can fill your car, but you don't see charging stations everywhere. So there's a barrier to get over sort of this charging phenomenon. The next one was just upfront cost. And I think in the last several years, cars have really come down to be more equal to a unconventional car purchase, but that was one concern. And then the final concern, especially as we talk to some of our commercial customers, if you have a bakery and you need a van to deliver, a Leaf may not be the perfect car. Or if you have a construction company, there aren't trucks on the market at this time. So as we looked at those barriers to adoption, we said, what can OPPD do, and how can we partner to help customers that want to move towards EVs get there? And so we were able to partner with some of the groups in this room, actually, to start to bring rebates and education to our customers. One of the, I think, the interesting things from my perspective was, as we got into this, there's sort of this paradigm shift. It's much like if you have a farm, generally you have fuel tanks on site and you put them in your machines from your house. You don't rely on a gas station. That's kind of where we're moving with electric vehicles. And what we found is 80 to 90% of people charge their vehicles at their homes. The other 10 to 20% of time is generally when you're driving far away. So it's this shift in mindset. I don't always see an electrical vehicle charger everywhere I go, but that's okay. I'm not driving the full range of my car every day to have to worry about that. So there was this balance of how do we help customers get the right charging at their homes, and what do we need to invest into public infrastructure? And so out of that, we were able to develop pilot programs that some of our team over there is going to be happy to talk about afterwards. We've got pilot programs that help with upfront cost incentives, getting chargers in your home, and some other great community partnerships. What we're getting out of that is starting to understand which customers are putting electric vehicle chargers in their homes, and what impacts are those going to have on the system. When we started looking at this, there's not as much of a concern of just having this huge growth that we're going to have to start adding power plants. It was more, what happens if I live here, my neighbor and my neighbor across the street and their neighbor all get chargers on their homes? What does that do to our transformer? Can our transformers handle that? So we're starting to be able to study that and prepare what's the right way to move towards this new future. And some people have gone as far to say the electric vehicles are kind of like what happened when air conditioning came on. The utilities weren't necessarily prepared for everyone to get air conditioning, so how do we get ready for electric vehicle charging? And the last thing is, we like to talk about is OPPD has been on this journey with our fleet for electric vehicles. Starting back when hybrids first started coming out, we have several fully electric vehicles. Trying to think, forklifts are electric. We have some bucket trucks that are able to go on electric battery when they're not running. So we've really been moving in this space to learn and grow alongside of our customers. The next piece, as we talk about some of our innovations with larger customers, is really partnering in the community with the economic development entities to attract new customers who are interested in renewable energy partnerships. And so you may be familiar with Facebook coming in, but this was a great opportunity for OPPD and the state to really lead, not only in Nebraska, but across the country, for how we partner with someone like a Facebook to allow them to purchase wind energy and to be able to bring them into the state. So that's been a very exciting opportunity. The next one I'm not going to say much on because you get a whole half-hour presentation on it, but we've been able to partner with great companies in Omaha and the area like UNMC to partner on large renewable energy projects such as UNMC's rooftop solar, and I will say no more. And then a couple other things that we're doing sort of from the holistic sustainability environmental stewardship perspective is saving with LED streetlights. So in the next 5 years, we're converting all streetlights within the territory to LEDs. We have about 298 streetlight customers, which are the towns, the cities, the Department of Transportation for the state of Nebraska to convert those. So you may start to see LED lights popping up. This is allowing us to reduce the cost by 25%. So that's passed on to these municipalities that pay the electricity bills, and hopefully that comes back to you in your communities. And this has also reduced energy use by 50%. So that's a pretty big deal if you think about all the streetlights in those 13 counties. The other thing is we have the Omaha Service Center, which is in North Omaha. That's where one of our centers that houses the big bucket trucks that you see driving around town. This building was opened in May 2011. It's a LEED Platinum and Energy certified building with about 60 kilowatts of on-site renewable energy. So this has been a great way to really learn about sort of the building sustainability aspects with one of our own facilities. And the last thing, that broad, holistic perspective of environmental stewardship, is we've made a lot of progress on a program called Prairies for Progress in partnership with foundations like Save Our Monarchs, Conservation Blueprint, Nebraska Environmental Trust, and the Bee and Butterfly Habitat Fund. So, as you may imagine, OPBD has a lot of land when you think about transformers, substations, transmission lines, power plants, that we conventionally would have to take care of and mow. Well, what we found is that we can actually partner with these groups to restore those to prairie and really support pollinators and other birds and natural wildlife in these areas. This has actually helped on reducing our O&M costs, which is an added bonus. And it reduces emissions when we're not out mowing all these acres. So we've converted over 300 acres, and we continue to look for opportunities and partner on land that we can turn back and help not only the monarchs, but other pollinators. We will be incorporating some of this into our community solar project. So we've been able to partner with our third-party builder to do that. And so we're excited to see how that fits into solar. So we'll keep jumping. So that's kind of a snapshot of what's going on now. Not only are we really working on growing the percent renewables that cover customer load, but we're working on all kinds of programs to really take on this holistic environmental stewardship perspective. So I'm glad we got to kind of cover some of that. So now the question is, what's next? As we've kind of studied and looked at strategy the last couple of years, we had an initiative called Integrated Energy Marketplace, where we really tried to understand how is the energy industry changing, how are our customers changing, and where do we fit into that? And out of that, we came up with a couple of key transformation drivers that are important to us and our customers. There's changes going on in California and Arizona and New York, but really what matters to Nebraskans, to OPBD customers. And so our transformation drivers are that customers are changing their expectations. Likely most of you in this room have changed expectations, whether it be your cell phone, how you pay bills, how you interact. We're all changing. What we also found is that purchase decisions, although are driven by other things, are still most often driven by economics. So even if customers are willing to pay for a certain service or a percent of something, they're still going to come back to, I have a threshold of money that I'm willing to spend on that, but I still have a budget that I'm trying to keep. Our load is projected to flatten. This one is interesting to me because not only is it a change for the industry, but the greatest cause for that is actually energy efficiency. And it's not even energy efficiency that we're forcing or promoting. It's every time you go buy a new refrigerator or a new TV or whatever appliance, it's likely more energy efficient than the last time. And so the whole industry is starting to see this flattening of load growth, despite the fact that we're adding housing developments and commercial developments in the territory. We're also seeing technology costs declining rapidly around solar, storage, EV, which is great for our customers, and it's great for us to be able to integrate those in new ways. And there's still opportunities to expand our products and services. And so we have a team that's devoted to working on that. So the key part of figuring out what's next is remembering our customers. And again, affordability and reliability are important to our customers, and we've continued to talk to them and understand that. But they also have environmental goals, and those are starting to take shapes differently. Some are local goals, some are personal goals, some belong to a national corporation that might have a goal they have to hit nationally. And so we're starting to see this take shape a little bit differently. We also understand that although we've made this steady progress towards nearly 40% next year of renewable energy covering our retail sales, not a lot of people know about that. So how do we make sure that we're telling the right story as we make this transformation? We continue to leverage partnerships in community, and that's what's so great about public power, is to be able to continue to partner on these projects around the community. And then finally, as I kind of mentioned with environmental, but understanding that our customers have varying priorities. And so how do we not look at all customers the same, but start to understand the different segments and the needs that they have? So with that being said, as we look to the future, we're really starting to integrate our planning with technology, with our customer input, and really understand how can we innovate our planning to go forward. As we look at new projects, whether that be large-scale utility projects to meet our renewable and carbon reduction goals, whether that be looking at non-traditional solutions, which is saying in the past, if we have load growth, we might add a transformer at a substation, we would add a large transmission project. These are all large capital expenses. As technology comes down, there's options to potentially replace that with a solar project or a small generator, energy storage, all these technologies that maybe we can defer a large capital investment, leverage some of these technologies, and make a better planning decision. So we're really excited to have a robust planning process, both from the large resource, but also from some of these new capital projects that are going to be available to us. So I look for that to be exciting in the next few years. I think with that, I'm not taking questions, but I think that wraps up the presentation. So I look forward to questions.
Thank you, Courtney. Please allow me to introduce our second speaker, Darren Dageford with UNMC and the Nebraska Medical Center. Darren is the Executive Director of Utilities and Energy Optimization for the University of Nebraska Medical Center in Omaha, Nebraska. He earned his mechanical engineering bachelor's degree from the University of Nebraska-Lincoln and is a registered professional mechanical engineer in the state of Nebraska. At UNMC, he is responsible for the central generation, distribution, control, and utilization of chilled water, steam, hot water, emergency, and normal power. He led the building automation, design, engineering, and sustainability teams on the UNMC campus, so he currently is doing all of those things. Since 2010, his teams at UNMC have reduced campus total energy consumption by 25% and peaks by over 28% while increasing campus building area. Darren has been with UNMC for over 20 years. He and his wife reside in a net zero energy and net zero waste home that they designed and built south of Blair, Nebraska. Thank you.
Thank you, Sally, and thank you for inviting us here today to tell us a little bit about the renewable story at the University of Nebraska Med Center. As Sally said, I'm Darren Dageford. I've been there for about 21 years, and I do all things energy at the university, or at the Med Center. Main project we're going to talk about is a project that we did in cooperation with OPPD. As everybody knows, the state laws in Nebraska, anything under 25 kW of a solar panel, the utilities are required to come in and just put in net metering on your house or whatever the small project is. When you get into bigger projects, there's so many unique things that go on with it that you end up in a partnership with OPPD. We have a great relationship with OPPD. We've been doing energy projects for as long as I've been there and 20 years before that. But anyway, we put on a solar panel array of about 500 kW on 3 buildings. That's a half a megawatt. That's 15 1,487 panels spread over 3 buildings. We like to call it the largest single solar installation in Nebraska until you get into the utility scale stuff. Maybe right, maybe not, but we're pretty proud of it. As you take a sky view look of the solar panels, this is actually the Michael Sorrell. It's basically the College of Medicine. That's a 319 kW array sitting on there. The building in the background up here is the Maurer Center for Public Health. That's 169 kW. And then over to the side over here, as you can't see, is Truls and I Institute. This is actually taking a look right on top of the Sorrell Center. Nice thing about solar panels is they're passive. You put them up, you plug them in, and they pretty much do their job. Most solar tours, about this point into the tour, everybody starts yawning because it is pretty much pretty simple. When you look at solar arrays. If you go to tracking, these are fixed arrays. But being an engineer, we're going to talk technical a little bit because that's what I have to do because I'm a licensed engineer. As you see, the solar panels actually laid flat in this arrangement on a north-south axis. We're actually laid with a 10-degree slope on the east-west plane. Kind of interesting why we did that, but I'll get back to that in a little bit. That was the picture, I'm sorry. Courtney had this picture. Obviously, we're on the same email strain when some of these pictures come out. This is looking on top of the Truls and I Institute. All looks the same, a lot of flat roofs. We're a small urban campus, about 146 acres in downtown Omaha. We have 8 million square feet, which is about 186 acres of under the roof. And so we got more space than we have dirt on the campus. So we're an urban campus. We don't have any place for parking. If anybody comes down, you know that. We are very, very intense. And so we look at this half a megawatt solar array, and that's 1,500 panels. That's a whole lot. Anybody want to guess what that is on our total energy consumption a year? It's 0.47 of 1%. It's less than 1/2 of 1% of our energy consumption. Great idea, great advertising, hard to move the needle. Okay, so when we look at this, there's 900 panels on Sorrell, about 47% roof coverage. Maurer Center for Public Health roof wouldn't actually support, all the roofs wouldn't actually support the solar panels and the extra weight. So is what we did, when you throw solar panels on, they want to act like wings of an airplane. So when the wind blows, they want to lift off, so you got to ballast them down. A lot of roofs aren't designed to take that kind of extra weight, so we could only get about half the roof covered, and we ran out of load on the roof. Maurer Center for Public Health, that was the one that it's only 34% covered, is 1/2 the building, the other half of the building we couldn't get to. And so you get a 55% of the roof area. Installed DC capacity is 513 kW. The AC side of that's considerably lighter. It's about 80 or 90% of that. Total yearly production, 650,000 kilowatt hours a year. Typical house in Nebraska, this gas heat's going to be about 11,000 kilowatt hours a year. So you're looking somewhere around 60 houses is what we put on our roof. Solar panels are interesting because what we put on at the here is exactly the same panels we put on a residential house. The inverter's a little bit different, they're a lot bigger, but other than that, what you do on a residential, what you do on commercial, on fixed arrays are pretty doggone simple. So he says, well, why don't we just go net zero on campus with solar panels? It's a great idea, it works, it's cost effective, it's got 20-year payback, but we're taxpayer funded. We get good cheap money, 15 to 20-year payback depending what there is. So I figured that out the other day. We need 315,701 panels at 345 watts each, which is 109 megawatts of solar panels to enter the energy production that we did in 2018. That covers 6.77 million square feet, which is 155 acres. We own 146 acres downtown. So we would have a perfect picnic canopy over the entire campus plus all the roads around us too, to be able to go to net zero on campus. So when you talk about solar on an industrial scale, and we are industrial, healthcare, when you look at the healthcare industry itself, if healthcare was a country, we would be the 7th largest emitter, or 7th largest polluter in the world as a country. So the healthcare industry has a lot of, they're very energy intensive. And so what you start seeing is buildings, 2-3-story buildings really seem to work pretty well, but as you get into larger scale, it's not really feasible for us to go total solar net zero. What we did is we chose the cheapest, quickest, easiest options. We got a lot of square footage of roofs. We took the quickest, easiest ones. We may get to 4 or 5 megawatts if we just keep adding panels, but ultimately we're not talking about, we can probably do what OPPD is doing in their first step. If they speed up, we won't catch them, but which I hope they do for different reasons, and we'll get to that. Currently we're producing about 83% of the projections of what we were supposed to do. Why is that? We got them online, everything put together, closed the breakers in the end of December. In January, we got snow and ice. January, February, 10 degrees, nothing melts, and we didn't get the melt this year, so we lost 2 months of production up front. And so what that does is by July, we're behind. We expect we'll catch up pretty well. When we talk about solar panels, typically when solar panels first come out, everybody wanted to optimize them. Well, to optimize, because the solar panel was way more expensive than everything else that you're associated with. And so what you ended up doing is to optimize a panel, you would put it at the latitude, you'd put the angle of inclination at the latitude that you're at. So we're at 41 degrees north latitude if you go onto Google Maps and you figure that out. And so everybody would tilt the panels at 41 degrees. And that would get the maximum because the sun would rotate back and forth around there. If we were at 41 degrees instead of flat, we would see another 15% production. We would probably see about a 30 to 40% increase in cost of racking and all the cost of the production levels. Can everybody hear me? I'm sorry. We good? If you can't hear me, somebody wave. Okay. Well, we would see a much bigger cost of production, or cost of installation costs go up, and thus we laid them flatter, and we were able to get more production, more panels, because the cost of panels has really come down over the years. It used to be we were $4 or $5 a watt when you're when 2010, when we put the first set of panels on our house, we were about $4.25 a watt just in equipment. A couple years ago we were at $2. You can buy them under $1 right now, $1 a watt for all the materials. And so you're really seeing the cost of the panel. You're not seeing the racking cost, all the framing and all that stuff, that stays pretty much the same, but the cost of the panels and the technology has plummeted over the years. And so where it used to be the real expensive part was a solar panel, so you really wanted to optimize that. That's a commodity now. It's like buying 2x4s. And so you can put a lot more of those down, not get as much production from each one, but on the overall production levels, you actually increase your layout. That's the magic of engineering. And so when we talk about we talk about commercial, large industrial, not a real good fit. Got a lot of roof space. It chips in pretty well, but it's not a huge contributor. But you look at, the industrial sector, that's 32% of the energy use, energy consumption in the U.S. Commercial buildings, 2-3 stories, that's pretty good to go to net zero. You can actually get, if you get a good dense population. Residential, this is ideal for residential. It's great, solar is great on residential because 30, 40 panels take care of what a typical house uses. And 30 or 40 panels, you got to face them, get them in the south facing and not have trees around and those kind of things. And they really pay for themselves in a reasonable number of years. And so it's a great option when you talk about that. So that 20% of the U.S.'s production is fair game for solar. You could dip into that commercial a few percent, 15, 20, or 30, 40%. Transportation, a little harder until we actually get engaged more in electric vehicles, get the shift over into those areas. When I talk about, when I say we got a net zero house, 2010 we built a net zero house, anybody can put solar panels up. Even an engineer and his junior and high school kid can install their own panels. This is us putting them on our own house. There's my electrical installer installing the microinverters. There's a lot of ways to do solar panels. Solar panels produce, excuse me, I'm fighting off a cold here, but solar panels usually produce 24 to 28 volts DC. So there's a couple ways to do that. You can put an inverter that takes basically 24 volts DC and turns it to 120 volts AC. Or you can line them up like a bunch of batteries and you can produce 120 volts DC and then change DC to AC, and those are called string inverters. When you get into big scale, you get into strings. The problem is you lose one inverter, you lose the whole string. When you do microinverters, what you do is you put the inverter right under the panel like we're doing here, and then you install the panel over the top of it, you plug it into there. You're wiring 120 volts AC. Everybody in the world that's an electrician or an engineer or do-it-yourselfer at home knows how to wire a circuit in your house. That's all you're really doing here when you're wiring the circuits. It's all 120 volts when you come out of microinverters. When you get over 3 or 4 kW, 5 kW, which is typical house size, you really start the break-even point on materials. And so that's really why microinverters are starting to really become very popular, because they're easy to do. You want one panel, you put up one panel. You want 20 panels, you put up 20 panels. Where we have to put up multiples of 6 or multiples of 12 or those type of things. This is real simple when you do microinverters. And so this is our house out south of Blair. I know it's a real imposing house, but we're net zero energy, we're net zero waste. The left-hand arrays, that was 4.1 kW that we put up in 2011, cost about $15,000 in materials. We put it up ourselves. The right-hand array is 3.7 kW. That was put up in 2016. It costs under $7,000. You can probably buy those at $4,000 to $5,000 now, but they still paid for themselves. A lot of other things we could talk about, energy conservation, but you're gonna have to do that off to the side because we're talking solar right now. I think we've seen the solar map. Solar is really very good in this area, so it's a good option. Because I'm an engineer, I'm required by state law to put up at least one graph in every presentation. And so basically, this right here is the solar panel production for the week of June 22nd to July 2nd, or June 22nd to July 2nd. It gives you, this is really what's happening with the arrangements. If you look right here, there's a lot of clouds blowing through these days. It was hot, but if you notice, the peak production here is considerably above 630 and 7.2. It was a lot hotter here. Solar panels have a negative thermal coefficient. The hotter it gets, the less they produce. So when Courtney was talking about floating these things, the cooler you keep them, the better off they are. So when you talk about shingles, there's no cooling on a photovoltaic shingle. So the production curves are really bad when they get hot. You got to be real careful. You got to put a lot more capacity on the roof to get the same output. But as you notice here, this was a bright, sunny, miserable peaking day for us. So you get this nice clean curve. You see the clouds blowing through, production goes up, cloud comes over, production goes down. When you're trying to manage peak on a 26 megawatt or 21 megawatt, it used to be 26, 21 megawatt campus, and you throw 200 kW to the wind, when a cloud blows by, my power plant guys are trying to control within 50 kW, and we move around temperatures and we do all sorts of bad things to manage load for about 3 hours a day. They were ready to pull their hair out. Then we get back over to the second and the third, and these are the 30th, first and second. These days were great. Solar panels come up, they produced right through, we get a level load profile, everything we do, we had even feedback on it. It was a really great day. When we look back over at this one, this is Truls-Sinai Institute. This is where the panels, there's many more panels. There's more panels than there is capacity in the building. So what you see here is the blue lines is the solar panels and the green line is the building load. We got more panels than we have peak building load. We export it. Now, since we're a small city, we have somewhere between 8,000 and 13,000 people on site every day. We have a few hundred people that can't move because we're a hospital. And so we actually just exported power from one building to the next. We're actually behind all the safeties and stuff. We're a small city, so we got to act like a small city, and we deal with OPPD like a small city, and they pull their hair out because we complain a lot and we have a really good relationship with them. But it's a very, we're a very aggressive, would you say, a very knowledgeable owner that I used to work for the utility for 7 years, so I've got a pretty good basis knowing what's going on. Oops, what did I do here? Okay. Anyway, enough of that. When you look at solar panel principles, when you look at the summer over here on the Earth, you see a high angle. So as the summer, as you tilt towards the Earth, you see very direct coming in. As the axis tilts away of the Earth in the wintertime, you see the angle really get a lot smaller. So what does that really look like as it comes into the building or comes into your house, onto your roof? This would be a typical roof display. This is why we say, oops, back up here. This is why we say at the March and September, summer, or the solstice, or the, anyway, in the middle of the year when, in the middle of March and September, basically that's when you're at the zero. And so if that roof is at 41 degrees, if your angle is at 41 degrees, you're at 90 degrees going into this panel. Then the Earth rotates 23 degrees one way, 23 degrees the other way, and you basically hold center. And if you ever remember, this is a matter of geometry. All it is catching all the parallel arrows, and when the arrows get flatter, you get less arrows. I mean, this is fundamental high school geometry. It's not too tough to size this stuff. As when we did it, we went in, okay, so what you really want is in the wintertime, you want them up. In the summertime, you want them back much flatter. You want them 46 degrees flatter. When you do tracking, you actually track them from the east to the west. And you actually follow them up. If you go single plane, you go east to west. If you go two plane, you actually go both directions. You do north, south, and east and west tracking, and you keep them pointed perpendicular to the sun. What we did is we went 10 degrees both ways on the east-west plane. This is actually the shop drawing. We actually have to ballast them to hold them down. And so this is really, this is basically, we lose the geometry. In the wintertime, these things don't produce very much at all. In the summertime, they really peak and they catch everything and they get a much wider load profile. So when we talk about, you saw OPPD, when they put up the 41 degree panels up on top of the roof facing south, they're optimized for there. This gives you a very different load profile. We create all sorts of headaches for OPPD's rate structure people because this is different. And there's 40 different ways to put panels up, and there's 25 of them in the state of Nebraska right now. And so when you try and model that and understand what's going on, it causes them trouble. They just need to speed up and get after it. Oops. Okay, so solar panels right here. Everybody says, well, what about hail and what about all that stuff? Yeah, they're glass. And on our house, we're south of Blair. We lived through the 5-inch hail, the $100 million damage at Woodhouse Ford. That same storm blew through ours. Our neighbor had $65,000 worth of damage. It broke walls. We never lost a panel. The wind was from the north. It carried them right over the top of the panels. We lost a window and we lost a whole bunch of holes in the siding, but we never lost a panel. Lucky. The very first year, in 2010, we had another big hailstorm come through. All the panels were in the garage in the basement. I hadn't gotten them up yet. Didn't have a problem there. Lost the roof, but we didn't lose the panels. And so when you talk about warranties, panels, you burn them out. They burn out at 0.6% per year to 0.75% per year, depending what brand. If you get the cheap Chinese crud, they're going to go at 0.75. If you get the little better grade stuff that are a little more higher quality, which we bought the Q cells, you're going to see a little less degradation. And so the warranty is on them is they'll be 90% of full power nameplate on the first year. You'll see 0.6 degradation and at least 83% of nominal power at 25 years. This is science. This is not experimentation anymore. This stuff does this day in, day out. If it doesn't do it day in, day out, they're responsible to replace them. Not that hard a deal. So why would a publicly funded medical science research university and hospital want to invest precious time and limited resources and tax dollars into renewable energy sources such as solar panels? Why in the world is the medical guy standing up in front of here saying, why do we want to do this? Well, number one, it makes economic sense. Number two, it's mission. It's our mission. Everybody says, got to pull that one down. Our mission is to lead the world in transforming lives to create a healthy future for all individuals and communities through premier educational programs, innovative research, and extraordinary patient care. So we put out a sustainability master plan. We have committed, I'm sorry, I got to quit doing that. We have committed that we're going to work towards reducing, in 2010, we started our sustainable master plan. We put out what we call audacious goals. If everybody looks up audacious, it means tough, it means hard, it means things that you really got to work at to get there. Our chancellor believes in audacious goals. He doesn't believe in putting out a 2020 goal that you meet in 2012. He believes putting out a 2012 or a 2020 goal that you might meet in 2022 because you had to work to get there. I'd like to give some advice to OPPD on goal setting, but that's, we don't get that opportunity. Anyway, but we said we're going to reduce annual building energy consumption by 25% by the end of 2015. We did it. Reduced an additional 20% by 2020. That worked out really good until the Buffett Cancer Center, the Lawrence and outpatient surgeries. We put 1 million square foot of 100% outdoor air systems online. We should put on about 6 to 7 megawatts of load. What we put on is about 3 megawatts, and we've lost most of it. I've buried most of that in energy conservation in the last couple of years, but I've been flatlined over the last couple of years simply because people give us money and they want us to go out and they expect us to go out and solve health problems. I don't understand that, but I guess that's the way it works. Our emissions goals, we're on to reduce greenhouse gas emissions by 30% by 2030. We're on track to do that. We had a net zero carbon emissions by 2050. That was the greatest thing when I inherited that. In 2015, inherited a lot of these goals. We made the 25% reduction, new control systems, really got aggressive about things. About how we controlled buildings, we cut down on wasted energy, made these big presentations, and we were sitting in the chancellor's office, all the vice chancellors, everybody's high-fiving, great, we made the goal, this is great. And everybody's going around, all of a sudden somebody says, let's do net zero by 2030, and I'm still high-fiving, all of a sudden Teresa says, what? And everybody says, oh wait, let's do it. And I just had the worst job on earth, just handed to me. I had the greatest job because 2050, it's somebody else's problem. I'm not going to be around in 2050. 2030 is my problem. Suddenly they made it my problem. But that's the way life is. And so 2030, we're going to be net zero. We got a long ways to go. Well, what really is driving us for energy? Well, when you look at air pollution, you look at this is some of the latest from the journal Chest. Known air pollution harms lungs and airways. They're attributed 500,000 lung cancer deaths a year, 1.6 million COPD deaths worldwide each year. Those are big stinking numbers. This is stuff that's correctable, people. This is what we did to ourselves. So when I say that we need to do something, we're going to do something about this. Preventive medicine, solving it before you get it there, is what we're after. CO2, or CO, carbon monoxide, carbon dioxide, nitrous oxide, ozone, sulfur dioxide, sulfur trioxide, all the NOx and SOx and all that bad stuff. Guess what? We put a lot of that stuff out in the atmosphere. Nothing like OPPD does, but I got to pick on them. But we do a lot of that. They were, 5th, 6th, 7th on their grid on energy consumption, 10th. We're in the top 10, but they don't really tell us because that's a secret, trade secret. But anyway, we're in the top 10. We used to be like top 3, but then somebody come in and started changing energy consumption, and we lost behind people. That's good news. Anyway, ultrafine particles move through the body, causing inflammation. Right now, 19% of all cardiovascular deaths are attributed to air pollution. 21% of all stroke deaths. All the bad things that happen, I had 2 or 3 slides of this. My wife says, you're going to bore people. But you talk obesity, change in blood pressure and health, cognitive dysfunction. We're making people stupider by the stuff we're pumping into our air. This is why we think energy is why everybody is engaged in that healthcare mission. This is how we engage all the maintenance, all the facilities people to make sure that we're all engaged in pulling the rope in the same direction. Crohn's, ulcers, appendicitis, mood disorders, acne, hives, dermatitis, easy stuff, sleep disorders. The other slides, the other slide talks a lot about reproductive health and what we're doing to our kids, which I killed that. World Health Organization calls air pollution a public health emergency. 90% of all of global populations exposed to toxic outdoor air, 8.8 million early deaths each year. We are actually moving in the wrong direction of life extension by what we're pumping into the air. And admittedly, everything we're pumping into the air is by our own volition. It is not caused by being able to survive. Some linkages for things like autism, Parkinson's. There's 70,000 scientific papers that push on this stuff. I just picked one. Air pollution now kills more people than cigarettes and tobacco. We're number one. In order to lead the world in transforming lives, creating a healthy future, we can't do this. We cannot build healthcare facilities fast enough to deal with the problems we are creating by all the pollution that we're dumping into the air. We have to go back to the source. And so we're moving back to the source. We're trying to lead the way. We can't lead the way for the world, but we can be an example. And that's what we're all about. Back up a second. Oops. Okay, now go forward a second. Chronic bronchitis, lost work days, the dollars. There's a whole presentation on that. We're going to get past that. Global greenhouse gas emissions by sector. Electricity and heat production is only 25% in the U.S., or is this, I think this is U.S., or global emissions from 210. I'm sorry, this is global emissions. Other energy sources is 10%. When you talk about methane coming off of fracking, when you talk about some of those things, that's in there. Industry, making concrete, one of the bigger polluters. Transportation industry, that's a huge, it's small here on a worldwide basis. In the U.S., it's huge. We're not going to do that by just greening up OPPD. We're not going to fix that by wind power. We've got to go to, we've got to open our minds up to other solutions. When you look at what what Courtney's talking about affecting, it isn't all just about windmills and solar panels. That's a very good start. Don't get me wrong there. It's a very, very good start, but it's a start. What we have to do is we have to change the way we think about things and move forward in multiple areas. Agricultural, forestry, and other land use areas, 24%. It's almost as big as electricity worldwide. Back in the areas of Buffalo Bill, when buffaloes roamed the plains, we had tall grasses. When you see all those roots, where are all those roots? They're carbon. This is called carbon capture. What we've been doing in agriculture is we've gone from what's on the left to what's on the right, the wheats, the shorts. We're taking out all the carbon out of the soil. What does that do? It makes the soil less absorbent. And so when we have huge rainstorm events, it all runs off. We have flooding. I know that doesn't affect us here in Nebraska, but because it was froze this year when it does, but you're going to see increased flooding. When the other thing that you see with carbon capture is desertification. Now, there's a lot of bad press, and I'm going to tell you right now, I'm an unapologetic farmer and rancher, or used to be until I turned to be a mechanical engineer. But this is actually a picture in Mexico from the Savory Institute website. And this is what you see. This is kind of typical of what you would see in a desertified landscape. You see this right here in the background. Now, what you got to look at is right here. 10 years later, it's green. They didn't do this with fertilizer. They didn't do this with grass. They did this with animals. What you do is regenerative agriculture, and and this is just a piece. This is not the whole answer, but regenerative agriculture, where you take cattle and you take sheep and pigs and whatever else, and you naturally restore what happened back with the buffaloes. When you talk about the buffaloes, there was a lot of predators, and so you had these little herds, and the predators would come in and they would chase the herd, and so the herds would stay together because you get spread out, you get killed. Fact of life, that's the way nature worked. Well, they would come in intensely. They would come in and poop and pee and all those things in these areas, and they would stomp it in, and they would all circle around, and pretty soon predators would push them someplace else. And maybe 2 years before it got back to that spot. And then they'd do it in the same spot, and they'd move it around. And what she found was a very intense growth rate of grass when that happened. Very much higher, sometimes 5 to 10 times more intense growth rates of grasses. And so when they were doing these things, we can go back and look at that. It's just a remarkable change. It's the same picture in the same place. This tree this tree right here just happens to be in the way, but you can see that right there in the background. When you talk about regenerative agriculture, what they do is by being very intense, and you're seeing this in the agricultural sector. There's a few people. There's Gabe Brown up in South Dakota. There's some Texas people that are shown on the internet. This guy down in Texas, he was running 4 times the cattle that was allowable by contract, because all these big areas, they know how many cattle you can put on per acre. He was 4 times the number of acres, and his ranch was much greener and much healthier, and he was supporting the deer, he was supporting all the other livestock on top of it by doing this regenerative agriculture. And so instead of stealing all the soil, when you talk about desertification, you're talking about 30% of the world's surface is actually being desertified because we're mismanaging it. We're mismanaging it in national parks. We're mismanaging it all over the country. I'm sorry, I should be looking at you because I got 5 left, right? Anyway, so as we talk about all these things, this is not something where this is my own personal, something that I throw out and that Sally has to put up with, because when you ask me about regenerative or you talk about where we need to go, we really need to talk about changing the worldview of what's going on. When you change your thinking, your entire worldview changes. We cannot think of this as OPPD's problem. We can't think of this as an industrial problem. We can't think of this as a transportation problem. We cannot think of this as one problem. We have to think of it as many solutions and many opportunities, and the opportunities to come together. And when one worldview changes, his perception, priorities, values, and relationships to everything in the world changes also. And so this is what the message is that I like to bring when we talk about sustainability. Why are we doing this at the Med Center? Those that healthy have 1,000 wishes and dreams, or those that do not have their health have one wish. Last week I fought off a summer cold over the 4th of July. What a miserable time. I had 4 days off. I was sitting around, my head was blowing up. All I could think about, I didn't want to go to a picnic, I didn't want to go to someplace else. I just wanted to be healthy. What are we pumping into the environment? We're taking people's health. We're not only stealing people, we're not only borrowing financially from our kids' future, we're taking their health, we're making them stupider. That's really not a very nice thing to do. There's no singular answer to the environmental crisis we've imposed upon ourselves. It takes everyone doing more than their fair share. Oh, I'm doing my fair share. No, you're not. Let's get after it and get it done. If you can do more, that's when you're doing it in multiple areas to save us from our own gluttony. And energy consumption is gluttony. That's where we're at. Our mission is to lead the world in transforming lives to create a healthy future. Preventive medicine is the only way I know to bail ourselves out of this, and that's to quit making people sick. We can't build the hospitals fast enough, and in the next few months you're probably going to hear an announcement that we're going to give it a big try, but you cannot build it fast enough to fix it. We need to lead the world in transforming lives to create that healthy future, and that's what we're about. Thank you.
Okay, thank you, everybody. We're going to go ahead and get started with our Q&A session. So the first question is actually for both of you. Any of your renewable energy projects implement the use of energy storage, like batteries or another system?
Yeah, so I can talk. Currently, none of our renewable energy projects have battery storage attached to them. That is something that our team, both on the utility scale side and some of the other smaller projects that we're looking into. There's a lot of announcements being had with lithium-ion, particular battery storage and solar, or battery storage and wind. And I think there's a lot of opportunity to incorporate that. What we've really been watching is both the price coming down and then some of the operational, not issues, but just challenges that come with that. So at this point, we're sort of monitoring and looking how we would incorporate those into future projects.
At the University of Nebraska Med Center, we were looking at the solar project. We actually designed half a megawatt of batteries into the project. When we started looking at cost, we started looking at a lot of things that were rolling with that. We said, hey, we were going to have a lot of relaying issues. We were going to get into a lot of departments with OPPD that was going to string us out. And so we basically dropped it at that point. We are pushing real hard. The University of Nebraska at Lincoln has a battery system. It's called a thermal storage tank, which is just another way of offsetting peaks and moving peaks around. Instead of doing it with electricity, you're doing it with water and offsetting cooling and those type of things. We're pushing real hard to bring that technology into the Med Center and looking at those type of things. And fundamentally, from the university or from the hospital healthcare standpoint, reliability, batteries and reliability, and having power 100% of the time, 100% reliability is what we're all about. Because when all things are going bad and power goes bad, there's just a few of us that are running towards the plant to make sure the generators are running, and we're doing distribution, and there's just a few of us crazy guys that are up on the roof making sure that we're getting cooling and all that stuff, because healthcare doesn't give a hoot what's going on outside. And so it is definitely something that we're looking forward to, working with OPPD and making that happen.
Thank you. Darren, you just kind of moved us right into our next question, which is, will the solar panels help to provide energy in the case of a power outage?
There's a lot of different ways to do solar panels. When you're talking about houses, or you're talking the typical way, if you're not shoving to a battery system, is you're actually looking for the 60 hertz pulse coming from the utility grid. And so like solar panels on our house, if we don't have the 60 hertz, 120 volts coming in from the grid, the inverter's shut down. And so in an outage, solar panels don't do a darn bit of good. Now, if you have batteries and the more expensive stuff that will create its own heartbeat, yeah, you can use solar panels in an outage. At the university, same way. We don't put those into our emergency portfolio. They go away when you lose the heartbeat. When you lose the utility, you lose the grid. And there are ways around that, but it's very expensive. And we're spending taxpayer dollars, and the odds of actually having that issue come to fruition and actually use that's usually pretty small, and the benefit is usually pretty small, and the risk is pretty high. And so we go for diesel generators. We do other things to deal with those issues.
Okay, thank you. Courtney, this next question is for you. Has OPPD partnered with any public school districts to implement renewable energy projects?
This is a good question, Kirk.
Not quite in your wheelhouse? Okay.
We sure would like to go that direction, but have not yet.
Okay.
So while I have the chance, I'm going to introduce Kirk SD and Tricia McKnight. They work on alternative energy projects as well, but they're more on the customer-facing side. So I really am focusing on large-scale utility projects, large customers. These two are behind a lot of the projects, or products and services on alternative energy.
Okay, great.
So that was a great plug.
Okay, great, thank you. Okay, so let's see, Courtney, this one is also for you. You did mention the wind project that's going up soon. Are there any other renewable energy projects on the horizon for OPPD?
Great question. So as I mentioned, we have two projects that will be coming online this year, the 160 megawatt Shoals Wind Energy Center in northeast Nebraska, and then our 5 megawatt community solar project. Those are kind of right now on the horizon. Obviously, as we look at going from 40% to 50%, we do have some additional room to move forward. And so, although we don't have anything announced at this time, we're really studying to understand how do we get to that 40 to 50%. What is the right technology? Solar has come down a lot. It has some capabilities. Wind continues to be very cheap in the state of Nebraska. So, although we don't have anything announced, we'll continue to look at how that fits in.
And we'll continue to put pressure on them, because if OPPD was 100% renewable, I'd meet my 2030 goals. And so the expectation is there, Courtney.
Thank you, Darren.
Okay, this question is actually for both of you. What advice or maybe warnings would you give to an organization who is interested in installing a large-scale solar panel project? Either one of you can start. Darren, do you want to start?
Go ahead.
Did you say selling a large scale?
Sorry, installing?
Installing.
A large-scale solar energy project, solar panel project?
Yeah, well, I think from the utility perspective, anytime a large-scale project is going in, the earlier that we know about it, the better. There's a lot of considerations on the utility side for system reliability and really safety. Kind of back to the outage question, when our lines go down and we have to send out linemen to bring things back online, we need to know where these projects are so they're not pushing electrons on a system that we think is down. So I would say from the utility perspective, involvement early on. That way if there's upgrades, if we're talking a large project such as a couple of megawatts or larger, sometimes depending on where you're installing it, there may be distribution system upgrades so that the system can handle that amount of generation. So that would be the big thing from our side of the house.
Our experience with that has been, obviously, anything over 25 kW is something that you got to engage the utility anyway, because there's solar panels become looking like any other generator. Our solar panels at our house, there's actually a disconnect sitting next to the meter. When they want to work on our circuit, OPPD truck shows up in our yard, they run around, they pull the circuit, they pull the fuses, and put their lock on it, because the solar panels, even though they're making 120, when it goes backwards through the transformer, it's 13,000 volts that they got to deal with on the other side. And so you can light people up. And so for safety reasons, you need to know what's going on. When you're talking large-scale solar, you're talking developers that are talking millions of dollars. Okay, a megawatt of solar panels at $2, $2.50, $3, whatever you're talking about, $1.50, the bigger the scale, you're into the millions of dollars when you're talking about those types of materials. And so that's not something that you're going to have the average Joe come out and take a bank loan out and drop in a large-scale solar and try and sell it to Courtney. She's probably not going to buy it because she's tough to get along with, but those type of things don't happen. On a small scale, it makes a lot of sense, and it's really pretty easy to do on houses. You know, you don't have to go on roofs. You can put them up on poles on the ground. My wife says she's never going back up on the roof again. The next solar panel on our property is going up on a ground array. That's fine. It's a lot cheaper to go on the roof because the racking's a lot cheaper, and right now the racking is the big cost on residential, or it's one of the bigger costs.
I think, and one other comment I'll make, Darren makes a good point that when you start to get into larger projects, you're going to be typically dealing with a developer. And I think not all developers are created equal.
Not anywhere close.
So, making sure you have someone that's done a project before, is familiar with working with utilities, the safety codes, et cetera, is always important.
Thank you. And Courtney, this next question is for you. You were talking about some ground habitat restoration. Is that ground habitat restoration done on the same site as the solar arrays? And if so, how does that work with the amount of shade?
Yeah, so this is something we will be incorporating partially into our community solar project. If you do research on it, there are some states in the U.S., Minnesota, Vermont are examples that actually require this on any solar project. We do not have that in the state of Nebraska, but OPPD really wants the opportunity to learn what that looks like. There's ways that you can have everything covered, and you do have to be careful, as the question asked, with the shading on the panels, depending on how tall your growth is. But there are ways that you can also do perimeters around the site. So we will kind of start with that path and understand how that works, and as we move forward to potentially other projects, I think we'll know more to integrate that.
Okay. Thank you. Okay, I think we have time for one or two more questions. So this is actually a question for both of you, but Courtney, I'm going to start with you. For individuals who are interested in supporting renewable energy, but maybe it's not the right time for them to put solar panels on their house or they rent, what's the best way that they can support renewable energy growth at OPPD?
So I think one of the programs that we have and that I talked about is community solar. And so this is the program that we launched this year, and we'd be happy to dive into a little bit more after this. But that's a great way to really promote our first attempt at solar. Other ways to support is as we move through, OPPD has a stakeholder process. So as we go through what we call the integrated resource plan that we have to file every 5 years, we have a whole stakeholder engagement which says, what are you willing to spend for different types of resources? What should we be looking at in our portfolio? Wind, solar, battery storage, something else. And so that's one way, even without putting money on the table, that you can get involved in what we're going to be doing in the future.
Okay, great, thank you. And this is going to be the last question for tonight. And Darren, this one is for you. I know you mentioned that, you know, the Med Center still has a long way to go to meet its net zero carbon goals. You just finished the large solar panel installation. So what's next on the horizon? Is it more energy efficiency? Is it more renewable energy? What are you guys looking at?
Well, to go to net zero, basically you either don't use it or you've got to buy it or you've got to produce it. Produce it, buy it, one way or the other. We are going to continue to hammer on energy, being the energy or the controls guy. We're going to do everything we can to drive our consumptions down. You're going to see, we hope to see electrification, because we use a lot of heat and we burn a lot of natural gas. And when you talk about carbon footprint, you're going to see a lot of natural gas, or natural gas plays a big role into our carbon footprint. We're working with OPPD on a lot of big initiatives that I would love to announce that are going to take huge steps forward, but we're trying to drag an anchor along to make these things happen, and it takes a while to make these things happen. There's a lot of things that could be happening in our future. We would love to do thermal storage. There's some resiliency. Resiliency is really in our future, because when you see the things happening in the climate that they are, that causes bad things to happen. And when bad things happen in the environment, everybody has to hunker down. But like we said, in the healthcare side, we have to step up. And so I think thermal storage does a lot of good things for us. We're actually investigating if we can get into a cogen situation. If you look at what's happening in Southwest Power Pool, there's a lot of natural gas being burnt right now to make electricity. But if you know anything about efficiencies, a natural gas turbine is only going to use about 40% of the energy that's produced to produce electricity on a very, very, very good day. The other 60% goes up the stack. That happens in coal plants, that happens in the thermal cycles is somewhere in the 30 to 40% usage rate. When you talk about cogen, what you do is you actually distribute generation, so we would actually be doing that generation on site, capturing that heat, taking that heat into the steam that we have to use anyway to sterilize, to heat, to all those other things on campus. And so instead of seeing a 30 or 40% cycle efficiency, you see a 70, 80, up to 90% cycle efficiency. We're going to be driving efficiencies by simply going away from steam and going to more hot water systems. I could spend all day telling you a ton of different ways we can do these things, and we're going to put a lot of political pressure on OPPD. Courtney's, we joke about it a lot, but that's political pressure as we're doing this, and we're going to ask our constituents of the owners of OPPD, everybody that's sitting in this room, to help us push OPPD to make those things happen. Because we don't want to see another 880,000 people, or 8.8 million people die or shorten their lives because of the crap that we're putting into the atmosphere.
Mm-hmm. Okay. Big changes, right? Sometimes they take a little bit of time and a lot of work to get them there, right? Sounds good. So thank you both, and thank you everyone for coming tonight. We're going to end just a little bit before 6:30 so that you have some time to visit the expo if you didn't get a chance to do so before. If you're still hungry, I still see some food on the table. Please take more if you are hungry. And you might have also seen on your seats that there are surveys about tonight's event. Feel free to please fill those out. There's a blue bin on the back table. We would like to hear your feedback so we can continue to improve this event for the future. Thank you everyone so much for coming. We really appreciate you having here and submitting your questions. And if you could please join me in giving our speakers a round of applause. So thank you and have a good night.